time to continue on our journey, and this is going to be leading now to stretches. And surprisingly enough, you did vertical stretches way back in Math 20-1. Do you remember when you had something like y equals to ax squared? And not only did the a tell you it was reflected over the x-axis, but it also meant wide or narrow. So remember, we had a graph that would look like this, and it would be our normal graph. And then if the a was a big number, it ended up making it narrow, or if the a was some sort of fraction or very, very small decimal, it made it wide. Well, actually what you're doing is you're actually stretching it. How do I know I'm stretching it? Well, that's what this whole section is all about. Let me show you how this works really, really quickly, and you'll see what I mean. Case in point, if you had some sort of graph that came around like this, if we stretch something by some sort of scale factor, we ended up getting a very, very narrow graph that looks something like that. Now, how do I know I've stretched it? Because if you take this value here, you actually get stretched to that value that's right there on the graph. Notice that this is a vertical stretch, so we're only affecting the y coordinates. Okay, the y's. We're not affecting the x's, because if you look, the x is in the same spot. Okay, look at over here. So if I got the stretch here, I'm going to stretch that guy way the heck all the way up to there. Look how much I've stretched. And the thing is, this is always going to be stretched by some sort of factor, some sort of scale factor, and we called it a scale factor. All right, so that number up front in that wonderful little thing that we called y equals a to the power of x squared there, that a value here is the thing that becomes our scale factor there. Okay, also the other thing I wanted to show you here is this. It is a vertical stretch because if you think about it, we're here, we're stretching in that direction. We're actually stretching away from the x-axis in this direction. So we're going to end up calling this a vertical stretch about the x-axis or away from the x-axis. Wow, I've told you too much already. Let's go out. I'm going to clean this up here. Let's go and let's stick to the notes here because I'm jumping all over the place. All right, so here we go. Let's talk about what a stretch factor is all about. A stretch factor is a type of transformation. Yes, you are in fact transforming the graph. Right? And all the transformations that we've done so far have been things like translations where we shifted left, right, or up and down. We talked about reflections flipping over an axis. Now we're going to have to do stretches. Okay, so it's a type of transformation where the distance of each x coordinate or y coordinate from the line that it's being reflected from, or I should say being transformed from. So if you think about it, that's that thing where you transformed away from the x in that vertical direction. So you're away from the x. Okay, and you're going to be multiplied by some sort of scale factor. Okay, this is going to just open up a really cool can of worms. Now, I kind of like the definition that was in your textbook. Take a look at this. It says a stretch is a transformation in which the distance of each x, so if it's an x, that's horizontal. If it's a y, it's a vertical. From a line of reflection is multiplied by some scale factor. Now, you're probably saying, what? Line of reflection? Well, think about it. If this was reflected, it would be from that line. See what I mean? So that means your scale factor is in that direction, away from this original line. Aha! Now you see what I mean. Okay, so a couple things to note about. Are we going to have a change in shape? Absolutely. We get narrow or wide. So this is unlike a translation or reflection. A stretch actually changes the shape. But here's something that's interesting. The orientation does not change. Think about it. We had a regular graph, we had a narrow graph, or we had a wide graph depending on that a value. Notice that all of them are opening upwards. The orientation has not changed. Aha! So let's move on and let's start looking at some cool stuff. I want to specifically concentrate on vertical stretches. One of the reasons why is because I want to work with something that you're familiar with. Again, this is a Math 20 concept. So let's go and take a look at this Math 20 concept right here. Okay, so recall, in Math 20, the A value in front of the parabola is the result of a wide or narrow graph. Stretch factor, value A. Great. So here's a nice little set of numbers. Here's the original parabola. Let's see how it's stretched. Okay? So all you got to do is take the x's, and we're going to just substitute the x's into there. We're going to square them all. We're going to get values for y. Right? Right. So 1 squared would be 1. Negative 1 squared would also be 1. 2 squared would be 4. Negative 2 squared would also be positive 4. And if you look, that's exactly what I graphed here in the red line. Ah, okay, so let's change these all to red then. So they're consistent. Sorry about that. Okay, so there's the red line. Now, here's what's interesting. I'm going to now change it to the blue line. So this is going to be this red line right here, all the way along here that you can see. Yada, da, 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 da. Perfect. Okay, so watch what happens now. Watch this. I'm going to put this one in blue. Okay, perfect. So think about this. If I put this 1 into here, right? This would be 2 times 1 squared. Well, 1 squared we already got. It's right here. Multiply by 2. Oh, this is a value of 2. Same with this. Negative 1 squared is 1 times it by 2. That would give us 2 again. This would be 4 times 2. That would be 8. This would be 4 times 2. That would be 8. So our blue graph has actually been stretched by a factor of 2. Well, let's prove that. Watch. Here's our original value. There is 1, right? 1 right here. Now, we're going to multiply it by a scale factor, and we're going to get this new value here. Look, I'm going to multiply it. I'm going to get this new point, which is right here. Boom. So that scale factor then is a multiple of 2. Don't believe me? Watch this. Let's go to 2. 2 we know right here gives you 4. Multiply that by 2. Watch what happens. We are stretching this value all the way up to here to 8. Oh, ho, ho. So 4 times 2 gives us this new value of 8. Watch again. It's kind of neat. So here's our first value, which is 1, multiplied by 2, which is this value here, gives us 2. Okay, and then here's our next value, which is at 4, multiplied again by 2, gives us 8. Isn't that neat? Now, if I wanted to, I can go to 3 and say, okay, there's 3, that would be 9, multiplied by 2 would be 18, but that'd be way the heck up here, and it's off our scale. And you can see that it's actually working out. That'd be multiplied by 2, be up there, 18 somewhere. Isn't that interesting? So we are, in fact, multiplying the y values by 2. Fascinating. Okay, so this illustrates our vertical stretch, and we notice that the a value only affects the y coordinate, because if you look back on this, the x value did not change. There's our original, there's our stretch. Look, this x value, there's our original, there's our stretch. The x value has not changed. So the x value remains unchanged, stretch the y. So vertical stretch then is considered a stretch about the x-axis. Now, why is it about the x-axis? Because about can be changed to away from the x-axis. Think about it. There's the x-axis. You're stretching away from the x-axis. So although it's not technically correct, you have to say about the x-axis, but if you keep in the back of your mind away from the x-axis, you're gonna be okay.